So hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company provide technological solutions across the world. Now here in our today's bootcamp session, we are going to see how we do the forecasting using LSTM mechanism, right? So far in our previous videos, previous sessions, we have seen how PyTorch is used, how regression techniques are used, and how they work in the back end, right? And I have also explained you with the real life example. Okay, so now today we are going to see how the forecasting is done using LSTM, long short term memory, right? Now what happened here, we will be taking the data, the historical data, and the historical sales data, right? For example, let me show you this. Here is inventory data, right? This is the historical sales data. Let me show you, open this and show you. Just a second. It's a very huge amount of data, so we need to wait for 1-2 seconds. Look at this, store item and the sales, nothing else. There is nothing else, stores item and sales, right? And now what we are going to do here, we will just take the data and then we will apply how forecasting is done, right? So with the help of LSTM, long short term memory layer, right? Now this is the scenario. Now we can use this scenario anywhere, wherever we want to do the forecast using LSTM layer, right? It is a type of recurrent neural network, right? Now let's go step by step. What is LSTM? First, in PyTorch, an LSTM layer is a type of recurrent neural network that we have already seen, layer designed to process sequential data. Now sequential data means the data which is received during the sequence of time, or for example which is arranged in the sequence of time. For example, sales data. Now sales data is a sequential data, right? 2022 data, 2023 data, 2024 data, like this. So it is a sequential data, and how it is processed, let's see this. There are two types of networks we are having, RNN, and that is the LSTM. Now you can see here is the input given, and working memory is this, and the output. Now working memory means for example, that is currently which is working, and long term memory means the memory in which the some past historical data is stored, just like human brain, right? At the same time I am connecting with you, but at the same time in the back end I might be thinking something about something else also. Human brain is having that capability that at the same time it is communicating with the other, and at the same time in the back end a person might be thinking something else also. So that is same concept is used here. Now LSTM means long short term memory. So this is the working memory, and this is the long term memory. That means in somewhere in this the past data is stored. Now you can see working of the LSTM. Now the architecture of LSTM features one additional component called the cell state, which is used to maintain the memory from previous time steps far back in time. Now the cell state means, as I told you, in human brain there are different what we say, the neurons and the memory store locations are there in the human brain, right? Same thing is same concept is used here. Here also cell state, look at this cell state, long term memory. Here is, where is it? Cell state is used in which the last memory is kept here, right? Here is new cell state, here is new hidden state. I will explain you all. Now see, this is the input gate. What is this input gate? The following subpart of the network is called the input gate, and is responsible for deciding what new information needs to be added to the long term memory, which is being maintained by the cell state. For example, let's give a daily life example. I am communicating with you, and in the during the conversation you said that today one politician is coming for visit in the city. Now this thing I will store somewhere, and remaining else I will just forget, because the remaining rest of the conversation is not that much useful. But what things to be kept in the memory, that is today, so there might be traffic diverted into the city, right? So this is my useful information, so I will just store that particular information in my memory somewhere else. Same thing is here, the input gate. This input gate decides that what type of memory is to be stored, or what thing is to be stored into the long term memory, into the cell, right? Then the forget gate. The forget gate is included in deciding what information from the long term memory to keep or discard. It is done using a forget vector generated using the current input and incoming short term memory, and is used in multiplication with the incoming long term memory. That means all in all, one forget gate decides that which things to be kept, which things to be forget. For example, just now I given you one example. I am communicating with you, and in the during the conversation you said that today one politician is coming for visit, right? Now on that particular day I will store that memory, and I will calculate that okay, the traffic might be diverted to any other route, so I will take care of that. But 2 days later, when the politician returned to some other state, in that case I will just forget that information. My brain will forget that information. My brain will decide, okay, now this information is not useful anymore. So here also same concept is used. Forget gate will keep track of what memory is to be kept, what memory is to be discarded, right? Now output gate. What is output gate? Is primarily meant to obtain the new short term memory or the hidden state vector for the next timestamp by using the current input vector, the hidden vector from the last timestamp or the previous short term memory, and the newly computed cell state or to the long term memory. Once again, the output gate is primarily meant to obtain new short term memory or the hidden state. Now see here, this output gate decides which information is to be sent to the new short term memory, right? There are some memory cells which are called as short term memory cells also, in which the information is kept for temporary purposes, right? Now here, how to use LSTM? Now see here, LSTM layer, it's a layer, raw demand data input, cell 1, cell 2, cell 3, and this cell 1, cell 2, cell 3, they all communicate with each other, and with the help of hidden layer, finally the forecasted demand is, it is just like that in our, that we have done in our regression technique, then we have done in our PyTorch techniques, everything. The main thing is that first take the information, distribute that information, then every create two or three hidden layers in which every information is internally connected with the next information layer, hidden layer, and then finally the demand is forecasted. Okay, so this was all about the LSTM, long short term memory layer, right? Now for this purpose, how to use this, how to do this in our real life. So for this, what we have done here, I have already prepared one example. We have taken here inventory data, right? Just sales data. It is better to rename this as sales data. Let me rename this, rename as sales data, right? Now this is the sales data, and on this sales data I have already shown you that sales data, and that sales data we will work on this, right? So let me create a new IPynoFile interactive Python notebook. Okay, so sales data LSTM forecast. Let's wait for 2 seconds. Sales data, that's it. Now first of all, let's come here. First of all, what we need to do is we need to import the necessary libraries. The very first task is, when we will work on any Python project, and when we will work on project something like these lines are to be kept on the top of the project. As soon as the project initiates, all the important libraries will be pulled here, right? So pandas, a very well known library, that is pandas pd, spd, numpy, as np, torch, then neural network, then optimization, plotting, min max scalar, and min square error. These are two different. I will explain you how it works. Now let's wait for 3-4 seconds. It is pulling all the necessary libraries. Right now the libraries are pulled here. Now what next? Now we need to pull the CSV. Now I will paste it. Now wait, sales underscore data. So we need to do this, sales underscore data. Now I am hitting the enter button. Now this sales underscore data, it is read. Now in the format of it is in the format of data frame, right? So if I keep this data head, means top 5 information, right? Data tail means the last 5 information from the end. Okay, now see here. Now convert the data to determine and sort by date. First of all, our very first target is, see, we have to predict, right, the sales, nothing else. The task is very simple: predict the sales for the future. That's it. We know the sales till current date. Now we are going to predict the sales with the help of this, okay, LSTM. Now convert date to determine and sort by date. Now date means the date which is the column there, and pd to determine date, and data short value, that is date. Now suppose if I click on this, now if I put this data, now see here, date, right, here is the date. Okay, now what next? Look at this. Now look at this. First of all, aggregate sales if needed, that is example sum sales per day, right? We need to group by the date, aggregate whatever the sales are done. So first of all, we need to group by date and sum it. For example, on 1st of January to, in the 1st of January we are having 5 sales, so we have to just group by date and just add whatever the sales done on that particular date, right? So now again if I click here, now here you can see 913,000, that means 9,13,000. So data, now it becomes 1,000 rows. Why? Because look at this, here on same day the date, the sales are given, so we have just added the sales. That is why group by technique which is used by pandas. So that is why this panda is very useful library. Now what next? Here you will see, use the sales column for forecasting. Again the same thing. Do you remember for the last few sessions what we were doing? We were just separating, making the data into numerical format. This is already in numerical format. Then we will separate the data, independent value in one variable, dependent value in one variable. So sales data equal to data sales value, right? After that, what next? Here you will see normalize the data. Now you can see here, normalize the sales data means scalar equal to minimax scalar feature range minus 1 to 1. So min-max scalar, what it does, it converts all the data into the minus 1 to 1 range, right? So sales scaled scalar dot fit transform Now it will fit the sales data and reshape it, right? After that, suppose if I change it, okay, if I make it enter, and then now prepare data for LSTM. Now we have to prepare the data for LSTM. See, data we are having, but we have to prepare it for LSTM layer. So how it is done? See here, prepare data equal to data sequence length 20 x and y. These are again dependent variables and independent variables. For I in range, length of data minus sequence data length, okay, x append data I, that means first data, and y append data I, first data plus sequence length, right? So in this way, what they have done, numerical return NP array. So here we have created the function, right? After that, you will see here the sequence. Now here we are sending the data. We will be sending the data here. Look at this. Sequence length is 20 sequence length, right? And then what we will do, we have decided that sequence length is 20. Now x y equal to, you will see prepare data sales scaled and sequence length. Now from here we are sending the data. Here we are sending the data, and then it will return the data like this. Torch tensor data, data type torch, and float 32. Now we will receive the data from this particular function. We have not given at this point of time. When we were at this point, at this stage, we have not given any data. It was just a function that we need to for this purpose. Then after that, in our next part, look at this, sequence length equal to 20 and x y, these are the variables, and prepare data. Prepare data is this, prepare data and sales are scaled and sequence length 20, right? So in this way we provide the data. After that, you will see LSTM. Now you see LSTM model equal to NN model. Again, we have created one model here, right? Now we have created one model here, in which we will see the input size, right? LSTM model. This is a by a fixed format that we need to write it as it is. Okay, so I'm just going to hit the enter button. Now what next I will be going to do here, initial model, initialize the model. Let me show you this. Look at this, initialize the model, loss function and optimizer, model equal to LSTM model, input size is this, criteria is nn dot mse loss, mean square error loss, and optimizer equal to optim dot adam, and then model dot parameters, right? So this is what we need this here, right? Just a second. Now our next step is to train the model, sorry, not loop, train the model. So for this purpose, we have decided that 60 repetitions will be executed. Okay, 50 repetitions will be executed, and here you can see the range, the function is it is written here, epochs. Epochs means just repetition to train the model, right? Here at this point of time we are training the models. Okay, now just enter. Now see here, the epochs are running one by one. Look at this, we have taken only 50 epochs. You can take as many epochs, because the more the epochs, the accuracy will be increased, right? Now just okay, now all 50 epochs are executed. After this, what we will do, our data is now trained. Now what we will do, we will just plot the model. Now look at this, this is just for plotting purpose. Now see here, training loss is decreased, epochs is increased. That means as the epochs increased, your training loss will be less. just like an example, for example, if I go to my friend daily, right? So I will come to know more about his how he start his day, or how at what day he will be available, at what day he will not be available. So my accuracy and my the way that I will understand him more and more, right? On which day he will be available, on which day he will not be available, right? What he eats in the breakfast, everything. Suppose if I go daily to his house, same thing is here. Repetition means the iteration which is done to train the model, and with these iterations we come to know the accuracy is increased, and the loss means the difference between the original and the predicted value. For example, if I go to my friend once in a week, or once in a month, or once in a year, I will not be able to predict exactly what type of person is that. But if I go to that person daily, and then I will come to know, okay, how the way he talks, the way he work, right? So this is how the repetition works. The more repetition, then your the accuracy will be increased. Okay, now what we are going to do, we are going to evaluate our model. So let me evaluate the model, right? Model eval, no grades, right? No gradient. Okay, now what next? Here you will see prediction to original scale. Just a second. Now look at this. Why prediction rescaled, and why actual rescaled? Okay, so if I hit the enter button, right, now it has done. Okay, now let me calculate mean square error. Now our next step will be calculation of mean square error, MSE. Now mean square error as calculated, and it comes here like 14964,257, right? So mean square error is calculated. Now what next? You will see here the plot, the library plotting. Now I am again plotting the complete data, right? Rescaled. So now you will see here, this blue is the actual data, look at this, and orange is the predicted data. Now with the help of this image you can see, that the prediction is our perfectly accurate. Whatever the sales data is there on the same pattern, our prediction is also done. That means this technique is maximum perfect, right? Completely fit technique, right? So as we know, this is accurate. So what we are going to do here, this was the prediction, based on the historical till current day date, right? Historical date till yesterday, this was done. But what if we want to calculate for future? In that case, what we need to do? So you will see here future prediction. Now here you will see, here you have given torch.tensor and the no grade, torch.no grade, right? So here we have created the function right now. After that, look at this, use the last sequence length value to the training set for the future prediction. Now last sequence equal to sales scaled sequence length, and future prediction, predict future. Look at this, this is the function, predict future and model, then the last sequence, then the future step. Okay, now what we are going to do, last sequence equal to sales scaled sequence length we have taken, and future predictions, and the future predictions that we need to extract. Now I'm going to hit the enter button, and now what next? Let's see this also. Rescale future prediction. Now rescaling the future prediction, how it is done, you will see here. Future prediction rescale scalar dot inverse transform NP array future prediction reshape -1 to 1. So reshaping, we are reshaping now. This is the completely technical part, so we don't need to go more depth in it, because it is the fixed process. We need to understand exactly what is the process, how we do it. Okay, now reshaping is done, right? After that, plot this value also. Now plot this value for the future. Now we are predicting for the future. Okay, so how it will be done, let me show you that. Now look at this. Okay, now look at this. This is blue color is the actual sales and future prediction. Now if you see this, a small line is here, right? Now this small line indicates the future, because right now here the blue color is over. That means the sale was done till at this point only, and from here for the future prediction, the machine has predicted the future, right? So this is how it works. Okay, then just give me a second. Okay, now what happens here, we have taken the data. Let's take a quick recap first, then only we will be able to understand clearly. First of all, see, we are just going to predict the future sales, right? This is our basic target, and that's the business requirement also. We are having the historical data till yesterday date, that is fine, but how to use it for the future prediction, and nobody will go through the long size CSV file. Okay, so what we do, first of all, we import all the libraries, necessary important libraries, because these are the important. So now after that you will see here loading the data set. Now load the data set means whatever the data is there, that we need to load it. After that, display the first row. Okay, that is fine. And convert date. Now we need to convert the date first, then we will sort by, right, values. After that we will add all the sum, right, sum of the sales. That means it becomes a very less lengthy table, that is only 1826 rows. Now use only the sales column for forecasting. So for the sales column, there is one sales column also, so we used to forecast that. So we have taken sales data in that particular column, right? We have created one variable. Now after that, normalize the sales data. Now normalizing the sales data means we have to make a scalar variable and min max scalar. What it do, it converts all the data into -1 to 1 range, right? So this normalize the sales data means converting the data into min max scalar, and then you can see here sales scaled. After that, we prepare a function in which prepare the data. See, whenever our data is, we are having the data, we have to prepare the data to put into the machine, right, or the function. It's not like just taking the data and put it into the machine, or we can say the software, right? After that, you see here sequence length is 20, and then we provide this complete data into this particular prepare data function. Okay, after that, LSTM model definition. So LSTM model data definition, that means almost all the models are almost the same, only a slight difference is there, right? After that, all the models are having mechanism almost same. Now see here the initialize model, just a second. Okay, now initialize model, loss function and optimizer. See, loss function is also activated, or we can say determined, and then the initialize model, loss function and the register, right? Now you will see initializing the model. After this initializing the model, you will see training the loop. Now our best part comes here, that is training the loop. Once the function is created, then we need to train the loop, right? And then we train the loop, we run the epochs here, and then we plot the training. Now this plot shows that the more repetition or the more epochs you run, the loss is decreased and the accuracy is increased. I have shown you in many of my previous videos where the accuracy increase after every repetition and the loss is decreased after every repetition. Now evaluate the model. We create a eval function, right, in which the data is feeded. After that, rescale. Look at this, rescale prediction to original scale. Now rescale prediction to original scale means whatever the original scales that we have, original data that we have till yesterday, and we will put the function into that only, and so that our prediction will also be calculated along with that data. And along with that data, if our prediction is given, so it would be easy for us to that whether you are progressing, right? So here also same thing is there. Rescaling, right? After this, calculation calculate mean square error. Mean square error is also calculated, and after that, here you will see mean square error is determined here like this. So okay, so this is how the mean square error is calculated. Now after that, we plot the data. Now here in this plotted data, you will see the actual data and the predicted data both, right? And it is almost in the middle, that means accuracy is perfect. After that, we again predict future. So future function is created, the predict future function is created. Inside this, we pass the data that we have, and then we see how it is plotted, right? So it is plotted like this small line, that means again it is going to increase the sales, right? So in this way, LSTM is used to forecast the data, right? So we have done here a quick recap here, and I suggest you to watch this video thrice, so you will have a better understanding. The complete game is here only, right? Just a second. Just a second. Here. Okay, so the complete game is here only, just taking the data, cleaning the data, then we make one variable inside which the sales data is kept, and then we predict the data with the help of these functions, right? So these functions are, and these are the fixed functions. You just need to supply the data, and remaining all the machine will do, right? So guys, today we are concluding here only, and tomorrow we will see with in our next session we will see we will discuss on some other interesting topics, and I suggest you and recommend you to watch this video once again, twice, thrice, and if you have any doubt, you can put it into the comment box. I will be happy to resolve your query, right? And then tomorrow we will see some other new topic in our next session. And those who are new to this channel, please like and subscribe my channel so that you will get the notification of the upcoming videos.